Okay, so Philae was released from the orbiter, and they knew they had trouble with some thrusters, but they decided to release it anyway. What can you do? You can't fix it in space. So they released it. It came down, but it had these little harpoons that were supposed to actually grab the planet and keep it there and anchor it down there. But they didn't deploy. So it hit hard enough that it actually bounced up, and they think about a kilometer back into space, but then it came back down, and when it landed back on the planet or on the comet again, they didn't really have any control of where it went. And it was supposed to work on solar power, and they were expecting to get 6 or 7 hours of sunlight a day, and they ended up landing somewhere in a crevice or a crack or something where it was all shady, and so it lost power, and it didn't really take much, or it wasn't very useful after that. The orbiter still worked, but it did not. So later on, the orbiter was able to take some pictures of the comet, and they found where this Philae landed up. So if you look at that little box right there, that's where it ended up, in that little craggy spot, poor little thing, and too much shade to have any energy. Well, New Horizons was the mission that went to Pluto several years ago. I think when it landed, or went by it in about 2015. It then was still a really good spacecraft. It already went by Pluto, and they're like, now what should we do with this wonderful, still running spacecraft? So let's go visit some of these comets out in the Kuiper Belt. So they planned another mission to go beyond, and they called this Ultima Thule. And when they got there it is again where it looks like a snowman, where you have a head and a body kind of stuck together. And they think this kind of happened by having two icy bodies that were orbiting, but when they impacted each other, they did it kind of gently, so that they actually attached to each other and didn't break each other apart. So there's our solar system. That kind of shows the asteroid belt in between Mars and Jupiter, and the Kuiper belt farther out. And there's how Ultima Thule looked when we were farther away from it. And there's the path that New Horizons traveled. And this is the formation of Ultima Thule, where you have those two objects that are gently orbiting each other and make contact, and since it's cold and it's icy, they kind of stuck together. So there's our comet. Comets can look like this when they're sublimating, but when they're not, they're funny looking. They're craggy, often look like snowmen. Don't have to, but that's what the core would look like within that whole blob when it's not sublimating. Alright, so there's the Kuiper belt again, so you can kind of get an overview of how that looks. So Pluto, as you know, got demoted from being a planet. So this is kind of the history of how that happened. So this was August of 2006, and there was a meeting of the International Astronomical Union. And they have these meetings every year or so in different parts of the world, and thousands of astronomers go to them. Well, they talked about Pluto during the week, and it was kind of, him-ha, him-ha. Well, they decided to vote on it on the last day of the conference. There were only 4% of the people there left. And they voted, and they said, this is how we are going to classify a planet. It has to be large enough to round out. So we talked about how the mass controls that. It must orbit the sun. So our moon, for instance, orbits the Earth, so therefore it can't be designated a planet. The object has to gravitationally clear its path. So when it is orbiting the sun, there's nothing else in its way. Well, this is a flawed definition because, as we saw, Jupiter has Trojan asteroids that are in its path. It doesn't run into them because they travel with it, but it's not a cleared path. So they made a new definition. They now have dwarf planets, so Pluto is a dwarf planet, Ceres is a dwarf planet, and so forth. And it was a big deal. A lot of people were upset that Pluto was no longer a planet. And if you go to Flagstaff and go to Lowell Observatory where Pluto was discovered, you'll see that, you know what? It's still a planet there. Always will be in Flagstaff. Well, there's one more place we need to talk about where leftovers ended up. This is Dutch astronomer Jan Oort in 1950. He proposed an idea for the origin of long-term comets that's still accepted today. He noticed that the orbits of some of these comets were really, really long, and that they couldn't have come from the Kuiper belt, orbit the sun, go back out, and come back again. They couldn't do it in this as many years as some of these were taking. So he proposed that there is actually like a sphere around our solar system, and that a lot of the leftovers ended up in the sphere as well. And that comets come in from that sphere at very wild angles, orbit the sun, and go back clear out to the sphere again. So these take many, many years to come out, in and out, hundreds to thousands of years. So there is also an area beyond our heliopause where the sun has influence. Our Viking spacecraft have passed this heliopause. The Oort cloud is thought to even be farther out than that. So we have short period comets. Their orbits do not extend past the Kuiper belt and have periods of less than 200 years. So those are the Kuiper belt objects just past Neptune. Then we have the long period comets. These comets take hundreds to 200,000 years to orbit the sun one time. Comet Hale-Bopp, which appeared in 1997, is a long period comet. It won't return to its perihelion near the sun again for almost 2,500 years. A long time to us, but a short time for a comet. About 5 out of every 6 comets that have been observed are long period comets. These are thought to come from the Oort cloud. Now there's just, this is a little sidebar. These look like comets, and we've found them in the asteroid belt. We're like, what the hey, why are we getting tails on things in the asteroid belt? There's another one. Now notice the tails are different. It's all different. So what they're figuring out is we have asteroid pairs. So we have a couple that may be orbiting each other. They might have smacked into each other and broken apart. So I'll read this. Studies showed that the asteroid pairs were activated at the point on the orbit closest to the sun and remained that way for somewhere between 6 to 9 months. Moreno thinks the dust is likely caused by sublimation of ice that was left exposed after the fragmentation. Asteroid pairs are common occurrences in the main asteroid belt. The pairs form when an asteroid breaks into 2 pieces, either from an impact, excess rotational speed, or in some cases 2 asteroids destabilizing each other's initial orbits. In other words, we've got two asteroids, but they contain water. They're inside of them, and if they smack into each other and that water is exposed to space, space is very cold there, that water will immediately sublimate and it makes those funky rays. So some asteroids do that, and it's just kind of an oddball thing, but kind of interesting. So there's our dinosaurs, and in is coming an asteroid, and make a wish.